I want to know if you've ever seen the rain. Well, on August 11th, 2014, we saw 74 millimeters of rain fall in under 6 hours, leading to widespread flooding of streets and basements. This is too common an occurrence in Windsor, but why? Well, in a natural environment, almost all that rainwater can seep into the soil or be absorbed by plants and evaporated. But in an urban environment, a lot of that water is instead collected by our stormwater system and whisked away as fast as possible. Out of sight, out of mind. That is, until we get too much rain in too little time, and our storm sewers can become backed up and overflow. And then we all get to bemoan the lack of flood insurance in Canada. Now, this problem becomes even larger when we recognize that a 1 in 25-year event, like that August 11th event, might become a 1 in 10-year event, or even a once in 5-year event in the face of catastrophic climate change. A typical engineering solution to this problem might be to simply build bigger storm sewers. The issues with this is that it can be very costly and disruptive. Think of all the road closures. For an alternative or even complementary solution, we can go back to our roots and look at that natural environment. By implementing simple green technologies like rain gardens, rain barrels, permeable pavement, and more, we can increase the amount of water that can infiltrate into the soil or be absorbed by plants and evaporated before it reaches our storm sewers. In doing so, we make our stormwater systems more resilient, more ecologically friendly, and even more aesthetically pleasing. Of course, there's a catch. That is that the performance of these green technologies can be more difficult to predict than that of our well-tried gray infrastructures like the storm sewers. So imagine for a moment that you're an engineer designing a stormwater system. You want to include these green technologies, but if a mistake on your part means potentially more flooding and more damage, you have to be sure. You don't want to be including a mystery box in your design. That is where my research comes in. By using a computer model which simulates these urban water processes and connecting it to an algorithm that can then find optimal combinations of these green technologies, we can produce cost-benefit curves that designers can use to select green technologies at different price points. They can also then see how well these technologies will perform in the area that we've modeled so that they can have confidence in the tools they're selecting. Essentially, what we're doing is we're transforming that mystery box into a green toolbox that engineers and planners can use to prevent climate change from flooding your basement. Thank you.